Now sometimes guys we might be a little bit mean and actually ask you to sketch the graph of a function that's not necessarily in this form. That is y equals a bracket x minus b cubed plus c. And in fact what we might actually do is ask you to sketch the graph of a function that might look a little bit like this.
Alright, so this question says sketch the graph of y equals negative 2 bracket 1 minus 2x cubed minus 16, showing all intercepts and commenting on any transformations that have occurred to the graph y equals x cubed. Now, like always, we need to go through and find your x, your y-intercepts, and your point of inflection. So let's go through and do that. Now for the y-intercept, we're going to make x equal to 0. So let's go through and do that. We've got y is equal to negative 2 bracket 1 minus 2x cubed minus 16, making x equal to 0 now. So we go y is equal to negative 2, 1 minus 2 times 0 cubed minus 16. Therefore we go through and simplify. Y is equal to negative 2 times 1 minus 2 times 0, well that's 0, so it's 1 minus 0 is just 1 cubed minus 16. Y is equal to negative 2 times 1 cubed, well 1 cubed is just 1, so it's going to be negative 2 minus 16, therefore y is equal to negative 18. And the coordinate of the y-intercept therefore is 0, negative 18. Alright, going through and finding the x-intercept now, so to find the x-intercept we make y equal to 0, and therefore we get y is equal to negative 2 bracket 1 minus 2 x cubed minus 16, making y equal to 0 now. You go 0 is equal to negative 2 1 minus 2 x cubed minus 16. And how many types of x have we got? Well, we've got just the one type of x here, so therefore we're going to use inverse operations to solve. So you get 16 is equal to negative 2 1 minus 2x cubed, because we add 16 to both sides. Dividing both sides now by negative 2, you're going to get negative 8 is equal to 1 minus 2x cubed. Cube rooting both sides now, so we're going to go cube root of negative 8 and cube root of this here is going to get us negative 2 is equal to 1 minus 2x. Now what we're going to do is subtract 1 from both sides, so it's going to get us negative 3 is equal to negative 2x. And therefore when we divide both sides by negative 2 you're going to get x is equal to 3 over 2. So the coordinate of this point is 3 over 2 comma 0. Now let's just go through and plot these points. I know normally we find the point of inflection first, but we'll go through and plot these points. So you're going to get 0, 18, which is going to be here. We write 0, 18, and we get 3 over 2, 0. That is 1.5, 0. So we go to 1.5, 0, and we'll write 3 over 2, 0. Now if we have a look at it, as you can see from these two dots, as you go from left to right the graph's going up, but if we have a look at the equation y equals negative 2, that actually implies that the graph is going down. Now why is this happening? Well, now when we look at it, this general form here really doesn't look anything like the form that you can see here, because for example there's a value out the front of the x, which in the general form there's no value out the front of the x, and our b value is in front of the x, whereas a b value is behind the x. So really we want to turn what we can see up the top here into something that looks like this. So let's go through and do that now. So what we've got is we've got y is equal to negative 2 bracket 1 minus 2x cubed minus 16. Converting that now, what we're going to have to do is we're going to have to rearrange the brackets first of all. So we're going to go y is equal to negative 2 bracket negative 2x plus 1 cubed minus 16. So all I've done is just swap the order of that. Now I can't have an a value out the front of the x, so what I need to do is I need to take out the a as a common factor. So I'm going to have y is equal to negative 2 bracket, and if I'm going to take the negative 2 out as a common factor, what I'm going to get is negative 2 bracket again x minus 1/2 bracket cubed, because that there hasn't really changed at all. I've taken it as a negative 2 x minus 1/2 and left it all cubed minus 16. So I haven't really changed it. All I've done is taken out the common factor of negative 2 there. Now what I need to do is expand this by cubing the negative 2. So I'm going to get y is equal to negative 2 times negative 2 cubed is negative 8 bracket x minus 1/2 cubed minus 16. That therefore is going to get me y is equal to negative 2 times negative 8 is 16 bracket x minus 1/2 cubed minus 16. Now you can see that what I've got is something that resembles our original form, that is y equals ax minus b cubed plus c. That is the one that you can see up here, where our a value is 16, our b value is equal to 1/2, and our c value is equal to negative 16. This means that the coordinates of my point of inflection will be at the point 1/2, negative 16. That's my point of inflection. Therefore I can go through and plot this now. So I've got 1/2, which is going to be here, and negative 16, which is going to be right here. So how's this graph going to look? Well, if I have a look at my a value, it's going to be positive really, whereas it originally looked negative, so it's going to be positive, and therefore my graph's going to go up like so. So what I'm going to do is just sketch a graph that comes up here, flattens out, and then goes up like you can see it there. And I go through and I write out the equation of the line. So I've got y is equal to negative 2, 1 minus 2x cubed minus 16. And the coordinates at this point here, the point of inflection, are at 1/2, negative 16. Now in order to comment on any transformations that have occurred, well, I have got a dilation factor of 16 from the x-axis. It has been translated half a unit right, and it's been translated 16 units down. So therefore, as you can see, the function y equals negative 2 bracket 1 minus 2x cubed minus 16 doesn't actually look as you might first expect, because we've got an a value out the front of the x inside the brackets here. So you always need to look to take that as a common factor before we go through and find points of inflection. It will just make your life a little bit easier. And that's how you sketch the graph of y equals negative 2 bracket 1 minus 2x cubed minus 16. Alright, so it's now time to press pause and attempt the following question, that is, sketch the graph of y equals negative bracket 4 minus x cubed plus 3, showing all intercepts and commenting on any transformations that have occurred to the graph of y equals x cubed. Now remember, when you're done, to press play so you can check your answers out against mine. Alright, so welcome back, and as you can see there's a fair bit of working out here, but like you've seen before, I've just gone through the same process of finding my x-intercepts, my y-intercepts, and my point of inflection. So finding out my y-intercept first, what I've done is I've written out the equation as you can see here, and then I've substituted in x equals 0 just here like so. Going through and simplifying now, I go 4 minus 0, well it's just going to be 4. When I cube 4 I'm going to get 64, and when I multiply it by the negative out the front that you can see there, I'm going to get negative 64. And then when I add 3 I'm going to get negative 61. So the coordinates at that point are going to be at x equals 0, y equals negative 61. Going through now and finding my x-intercept, I make y equal to 0, so I've written out my equation of my line once again, make y equal to 0 as you can see here, and what I do now is I have a look to see how many types of x I've got. Well, I've only got the one type of x, so what I need to do is use inverse operations or BODMAS in order to be able to solve this. So I subtract 3 off both sides. This gets me negative 3 is equal to negative bracket 4 minus x cubed, because the 3 and the negative 3 cancel out. Then what I do is I divide both sides by the negative here, so that's going to get me 3 is equal to 4 minus x cubed. Now what I need to do is cube root both sides, like so, and that's going to get me cube root of 3 down there, and the cube root and the cube are going to cancel out, leaving me with 4 minus x. Now what I need to do is subtract 4 off both sides, like so. That's going to get me cube root of 3 minus 4, and the 4 and the negative 4 will cancel each other out. Now what I need to do is divide both sides by the negative, so when I divide everything over here by the negative, it's going to get me negative cube root of 3, and the negative 4 divided by negative actually becomes a positive. So what I've done here is I've written it out in the different order. I've written positive 4 first, with the negative cube root of 3 afterwards. Now for your own knowledge later on, that's going to approximately be equal to 2.56. And coming over to the left a little bit, the coordinate of this x-intercept is going to be at 4 minus a cube root of 3, 0. Looking to find the coordinate of the point of inflection now, what I need to do is double check that I've got my equation in the same form as the power function form. So if we have a look at here at the equation, we've got y is equal to negative bracket 4 minus x cubed plus 3, and the power function form is y equals ax minus b cubed plus c. Now if we have a look, the x is first in the brackets, and in our function this is not the case. So what we need to do is rearrange and make x the first one in the brackets, and what you can see now is we've got negative x plus 4, and we shouldn't have anything at the front of the x. So what I do is I take it out as a common factor, and in order to do that I need to keep it in the brackets cubed, and then what I need to do is write each one separately as being cubed. So that is the negative cubed and the x minus 4 cubed. Now the negative cubed gets me a negative, and the negative times negative is a positive, so I don't need to write anything else there, leaving me with x minus 4 cubed plus 3. So our a value is equal to 1, our b value is equal to 4, because it's the opposite of the negative, and our c value is equal to 3. So therefore my point of inflection is at 4, 3. So now what I'm going to do is go through and plot each one of these points. So the first one being the y-intercept, so that's at 0, negative 61, so it's around about here, and I'll write 0, negative 61. The next one being my x-intercept, which is at 4 minus the cube root of 3. Now like I said before, this is actually roughly at 2.56, so go up to 2.56, and we're going to plot the point there, and we're going to write in the coordinate of the x-intercept, which like I said is at 4 minus the cube root of 3, 0. And finally we're going to go through and write out the point of inflection, which is at the coordinates 4, 3. Now that's 5, 10, 15, 20, so 4, 3 is going to be roughly around about here. And we'll write 4, 3 like so. Now all I need to do is go through and plot the points. Now if you have a look here, my a value like I said is 1, so therefore the graph is going to look like it's going up like so, and as you can see that's what's actually occurring with the dot, so that means we know we're on the right track. So we go through and we plot the points. We'll start off at the point of inflection. It's going to go down through here and through the y-intercept like so, and we put an arrow at the end there like so, and then for going up from the point of inflection it's going to come up like you can see there. So now what we do is we go through and we write out the equation of the line, so that is y is equal to negative bracket